Hey everybody, let's greet each other properly. This is Mr. Ainsworth. Good morning. Hey, we're going to get into the second half of this lesson here. I went over in part one examples 1 and 2, and in that lesson I went over how to find the vertex here, how to find the vertex and the axis of symmetry, graphing the vertex and the axis of symmetry, and using that to reflect points. I talked about how to determine the right x values in your table so you can plot the correct points. Talked about how to sketch the parabola and finding the x-intercepts both graphically and algebraically. And I also talked about the domain and range. So I talked about a lot. And in this lesson here, in examples 1 and 2, illustrate all those ideas. But what I need to do is go over more examples because, you know, 2 examples is not enough to get really, really good. And that's why in this lesson there are 6. Okay, and here's the second one here, example 2. I went over that in the prior lesson. So let's go over example number 3 here and see how I handle that. Okay, step 1, express it in standard form. Well, take a look at it here. It is in standard form because standard form is y equals ax squared plus bx plus c. And so if I write down the equation or the function right underneath it, you can see a, b, and c. It's pretty easy to identify. Here's a is 1, b is -4, and c is -5. So a is 1, b is -4, c is -5. And you want to take these values and you want to substitute them in here to solve for not only the axis of symmetry, but also the x-coordinate of your vertex here. The axis of symmetry gives you the x-coordinate, and then after that you substitute it in to the function up here. This is our main function. Let me highlight it. And then you're going to get the y-coordinate afterwards. So let's go for it. All right, so we have x equals -b, which is negative of -4, all divided by 2 times a, which is 1. Well, I know that a negative of -4 is +4, and I know that 2 times 1 is 2, so I know that x equals 2, because 4 divided by 2 is 2. This is called the axis of symmetry, and it's a vertical line for this parabola because we know that these parabolas open either up or down when the x is being squared here. In Algebra 2, in a couple of years, you're going to study the parabolas that open up left and right. Okay, but when the x is being squared and y is not, you got a parabola open either up or down depending on the coefficient of a, which happens to be 1 in this case. And from experience, you know that opens up. All right, we're going to take this x equals 2 here, and we're going to substitute it in this vertex here. We know it's 2 comma something. The question is, what is y? So we got to find f of 2, which means we got to substitute my x equals 2 in the function. Okay, so what is that? Well, we got y is equal to 2 squared minus 4 times 2, all right, minus 5. What's that? Well, let's figure it out. 2 squared is 4. That's 8 minus 8 here, minus 5. Y equals, let me see, -4 minus 5, so y equals -9, working from left to right and using the order of operations. Now, if I went too fast, just think about it. 4 minus 8 is 4 plus -8, or -4. And -4 plus -5 is a -9, because a negative plus another negative is a bigger negative. Okay, a negative plus a bigger negative is a bigger negative. So I already know my vertex. Okay, the vertex, let's just write it out here, is 2 comma -9. 2 comma -9. My axis of symmetry is x equals 2. So let's graph this. All right, now 2 comma -9 is right 2. I'm just labeling the x-axis here so we can see things better. All right. So right 2 and down 9. 3, 4, 5, 6, 7, 8, 9. So 2 -9. I'm going to label that 2 -9 right here. And let me see, my axis of symmetry is x equals 2. It's a vertical line, as we've been discovering all through my 3 lessons and through every single example. This is a vertical line passing through 2 on the x-axis. And I use that to develop to reflect points because I know about parabolas and the fact that they're symmetrical. Now, once you graph the vertical line and the axis of symmetry and the vertex, you pick the points to the right, which are these points right here. I want to start my table at 3 because I need some points to the right so I can reflect them. So 3, 4, and 5. So let's go ahead and do that. 3, 4, and 5. And let's take our x values and substitute them in our function. So let's go for it. We got y equals, okay, I've got to substitute x here and here. And wherever I substitute x, I give it a hug. So we got 3 squared minus 4 times 3 minus 5. What does that equal? Well, 3 squared is 9 minus 4 times 3, 12 minus 5. That's negative 3 minus 5, or negative 8. If you didn't understand that, well, just add the opposite. Negative 3 plus negative 5 is negative 8. And that's the point on the graph. On the second one, y equals 4 squared minus 4 times 4. All right, minus 5. What is that? Well, it's 16 minus 5. These cancel because 16 minus 16 is equal to 0, and you get negative 5. Third one, 5 squared minus 4 times 5 minus 5. That's 25 minus 20 minus 5. That's 5 minus 5, and that's 0. Okay? So there we go right there. We're going to graph these. We're going to plot, and we're going to reflect. Everybody say plot and reflect. Dustin Vaughn? Ah, the good man, good man. That was my son in there in the background. Okay, so we're going to plot 3 comma negative 8 and then reflect that point. Okay, so here we go. Let's plot and reflect. We've got right 3 down 8. There we go right there. Reflect it. 1 unit across the axis. Next point, 4 comma negative 5. Right 4 down 5. There it is. Reflect it. It's 2 units away right here. So reflect it across 2 units away. Again, this is 2 units, and this is 2 units, right? So reflect it. Reflect each point. I've been doing this in every single example, so hopefully you've started to understand how to reflect a point. You take a look at the distance right here. That's 2. And then reflect it 2 units on the other side, okay? This distance is 1. That distance is 1. All right? Next one, we got to plot, let me see, 5 comma 0. So 5 comma 0 is right here. All right, let's go for that. You can see it's 1, 2, 3 units away. 1, 2, 3 units away. So it gets reflected over here, 3 units on the other side. All right, and then you go ahead and graph your parabola. Draw a nice smooth curve through the points here. Okay, that's not bad actually by hand. There you go. Put arrows at the end so that you make sure that you know that it continues upward forever. All right, like I said, 3 units on the right, 3 units on the left. You reflect it. Same distance on the opposite side. All right, same distance. Okay, opposite side. So make all these key notes right here. Take really good notes because guess what? You're going to use them in your homework. Okay, and in your practice. Part of being a good student is taking good notes. All right. Now, what are the y-intercepts? Well, you can see them graphically. I see one right here at negative 1 comma 0. I see one right here at 5 comma 0. These are called x-intercepts. Why? Because they intersect, or this is where the parabola intersects the x-axis, right here and right here. All right, so negative 1 comma 0 and 5 comma 0. So it's pretty easy to determine these on the graph, but you have to be able to solve for them, okay, algebraically without looking at the graph. So how do we do that? Well, it's pretty simple because all you have to understand is that the y-coordinate's always 0. Any point on the x-axis, the y-coordinate's always 0. So every teacher says, okay, set the y-coordinate equal to 0, set y equal to 0, and solve for x. I don't care whether you're dealing with linear functions, quadratic functions, cubic functions, trig functions. It doesn't matter. Okay? You set y equal to 0. You got to remember that, guys. All right? Which means you got to set y equal to 0 right here. So I have to solve 0 equals. All right? 0 equals x squared minus 4x minus 5. We got to solve that. But the good news is that you already know how, because we spent 2 to 3 weeks prior to this solving quadratic equations, and anybody that's been paying attention knows that you should factor first if possible, okay? All right, so do you know two numbers that multiply to -5 and add to -4? I'm going to put a times symbol here and a plus symbol here. Do you know two numbers that multiply to -5 and add to -4? Because I do. All right, they're called -5 and 1. -5 times 1 is -5, and -5 plus 1 is -4. All right, let's do some factor by grouping and split the middle term here. We got 0 equals x squared minus 5x plus 1x minus 5. Okay, I split the middle term. Minus -4x was rewritten or split up into two terms called -5x and x because they combine to the middle term, right? That's how we do the factor by grouping. We use our middle factors here. All right, so let's factor out the GCF. Okay, I see out of the first two terms is x. There's no GCF out of the next term, so just give it a hug and put a 1 in the front as a coefficient. All right, I see a common binomial right here, and that's called x minus 5. I need to factor that out. Oh, got to bring down the 0 equals here. Multiplied by the remaining terms, x plus 1. That goes here. So x plus 1. Let me make that a little bit darker here so you guys can see that. X plus 1. There we go. All right, and then now we have what's called a zero product. All right, that means that one of these has to be 0 in order to get 0 here, because we know that anything times 0 is 0. So what would make this 0 right here? Well, we know that 5 minus 5 is 0, so x must be 5. And we also know that -1 plus 1 equals 0, so x has to be -1. And believe it or not, those are the x-intercepts done algebraically. And guess what? This makes sense because if you look above, all right, take this and you look above up here, look above, you'll see, and I'll go right up here, that those x-intercepts are right here, -1 and +5. Look at that, -1 and +5. There they are. So you can see it graphically pretty easily, but you can also get them algebraically without the graph. Make sure you're able to do that. Okay? Now, the domain for all parabolas is the set of all reals. So let's go ahead and write that down there, set of all reals. And the range, well, this depends on the vertex. So let's write that down. Depends on vertex. So what you have to do is look above. All right, so let's look above. Let's look at the graph. Now the minimum I noticed is 2, -9, and I noticed this kind of represents like a valley. Okay, so as I was saying, this represents a valley here and not a hill. And as we know, valleys don't have high points. Well, they have low points, okay? And we call low points, we call them minimums. Okay, so this vertex here represents a minimum vertex, okay? A minimum point on the function. In other words, a low point, okay? But the technical word is minimum. The question is, what's the minimum y value? Okay? And what we want to do is figure that out. So let's take a look at some points here. Look at this point. I'm going to call this one A, this one B. I'm going to call this point C, this one D, this one E. And this one I'm going to call V for vertex, okay? And take a look at the points here. This point A here, the y-coordinate is 0. You can just look straight across on the y-axis. That's 0. At B, well, it's -5 because, well, this is -4 and that's -5. The y-coordinate is -5 there. Here it's -6. At D, it's -7. At E, it's -8. You can tell by looking at the graph here that the y values are decreasing. They're getting more and more negative. We're getting smaller. And they're decreasing all the way to the minimum y value, which happens to be -9. It's right here. This is called the minimum y value, and it happens to be equal to -9. Okay, min value. The parabola doesn't get any lower than that. All right, we call that the minimum y value. Now, why does that help us? Well, we know that all these other y values, they lie above it, right? Because this parabola opens up. So all these values like 0, -1, -2, -3, -4, -8, all the way up to -9, including all these fractions right here, are greater than this because they lie above it. So the y has to be greater than or equal to the minimum y value. And that's why when we talk about the range, which is the set of y values, okay, is all y values are greater than or equal to that minimum, which is -9. Okay, it depends on the vertex. So you guys got to remember that. You have to look at the graph, all right, and to determine the range, you have to look at the vertex. All right, if the graph lies above it, then all the y values are greater than or equal to that y value in the vertex. All right, it just takes getting used to. You know, you have to do a lot of these, and when the light bulb goes on, this is easy. All right, let's try another one. We've got example 4 here. All right, let's express in standard form first. All right, y equals x squared minus x minus 6. All right, in this case, a is 1, b is -1, c is -6. So let's state that. A is 1, b is -1. All right, and c is -6. I'm going to take these and I'm going to substitute those in and find my axis symmetry first. And also, hopefully, if you're watching this video here, you've already done your homework. If you haven't and you're watching, you should pause the video and get started here and then work on it and then press play when you're ready and check it. But you shouldn't just be watching and copying. You should be interacting with this, pausing and playing. All right, working, checking your work, and so on. So hopefully you're doing that. Okay, next one. We got x is equal to -b. Now, b is -1 divided by 2 times 1. That's 1 divided by 2 or a half. So my axis symmetry is equal to 1/2. And remember, that's a vertical line as I keep on repeating myself. All right, it also gives me the x-coordinate of my vertex. So I know the vertex is 1/2 comma something. How do I get that? Well, I substitute in my function here. So I get y equals x squared minus x minus 6. So I got to substitute wherever I see x in here, right here and right here. So I've got 1/2 squared, make sure you use parentheses there, minus 1/2 minus 6. Well, that gives me x equals 1/4 minus 1/2 minus 6. And as you guys know, we have to have common denominators here. So as you saw me do in my prior lessons, I've got to form a common denominator. So I multiply this by 2 halves, and I get 1/4 minus 2/4 minus 6. Well, that's 1/4 minus 2/4 is a -1/4 minus 6. All right, and that's a -6 1/4. And so I know my vertex now. I know that y is -6 1/4 and x is 1/2, so my vertex is 1/2 comma -6 1/4. So let's plot that. All right, so I've got 2 pieces of information that are important to me. I got positive 1/2. This is 1/2 here because that's 1, so 1/2 is halfway. Well, I take that back, the scale's changed. This is 1 and this is 1/2, so I got to go right 1/2. Down 1, 2, 3, 4, 5, 6. This is 6 1/2. So 6 1/4 is right here. It's a half of a half. So it's right here. Here's 6 1/4. -6 1/4. -6 1/4. So I've plot that point. Okay, and that's called V for vertex. 1/2 comma -6 1/4. All right, what are my other points? Well, what am I going to pick? Well, I'm going to pick 1, 2, and probably 3. 1, 2, and 3 points to the right of my axis of symmetry, which I need to graph, so I'm graphing that now. So I've got the axis of symmetry here at x equals positive 1/2. Remember, it's a vertical line, as I keep on saying, and I'm going to use it to help me graph the points. So I'm going to pick these points right here, 1, 2, and 3, because they're to the right of the vertex. So 1, 2, and 3. So y equals, I'm going to take this and substitute it in, 1 squared minus 1 minus 6. That's 1 minus 1 minus 6, or that's just -6. 1 minus 1 is 0. 0 minus 6 is -6. Next one, 2 squared minus 2 minus 6. 4 minus 2 minus 6. That's 2 minus 6. That's -4. And then last one, 3 squared minus 3 minus 6. That's 9 minus 3 minus 6, and that's 0, because 6 minus 6 is 0. So I've got to plot these and reflect them. Everybody say plot and reflect. Let me hear it, D. All right, here we go. That was my boy again. All right, 1 comma negative 6. Let's do it. All right, let's plot it. 1, negative 6, right here. Reflect it, right here. There we go. That's easy. And let me see, 2, negative 4. Right 2, down 4. That's 1 and a half. 1 and a, let me see, a half and 1 right here. So again, opposite side, same distance away. And 3, 0. So right here, so that's 2.5 units away. So we go a half plus 2 more right here, and it gets reflected on the other side. And then you graph your parabola. Okay, there you go. All right, not too bad. So all those points in red I had to hit. All right, there we go. So you plot and reflect each point, as I keep on saying in every single problem. Okay, reflect the points, guys. Opposite side, same distance away. Okay, like I keeps on saying. So like this distance right here, that is 1.5 units away. All right, this is 1.5 units away from the axis of symmetry. All right, I can see already my x-intercepts. I can see one here. I can see the at negative, this is negative 2, so negative 2 comma 0. I can see one here at 3 comma 0. These are called x-intercepts because it's where they intersect the x-axis. So let's go ahead and write those down. I got negative 2 comma 0 and 3 comma 0. And I also see that this vertex, because this is like acts like a valley, represents a minimum, okay, or low point of the function. All right, and I can see that this right here, this is the minimum y value. I'm going to write down min y value. Because all these other y values, like this point right here, well, it's a negative 4. This y value, it's a negative 3. This y value, negative 2. This y value, negative 1, and so on. All these y values are above the vertex, and they've got to be greater than negative 6 1/4. So my minimum y value equals negative 6 1/4. That means all the other y values are greater than it, greater than or equal to it. So already I can see the range. Okay, my range is greater than or equal to negative 6 1/4. As you guys already know, the domain is the set of all reals. Okay, last thing we need to do is find the x-intercepts algebraically. All right, we set y equal to 0 as I keep on repeating myself, okay? So I'm going to put 0 right here. So I've got to solve 0 equals x squared minus x minus 6, and I have to play the factor game. All right, what two numbers multiply to negative 6 and add to negative 1? All right, you guessed it, negative 3 and 2. Negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. So let's do some factor by grouping and split the middle term. We got x squared minus 3x plus 2x minus 6. Factor out the x here. Factor out the 2 here, because they're both even, so they have that in common. I see an x minus 3 in common, so let's factor that out. I'm going to multiply it by the remaining factors, x plus 2. And then I'm going to ask myself some simple questions. You know, what number minus 3 is 0? It's got to be 3. You know, 3 minus 3 is 0 usually, especially today. And then since negative 2 plus 2 is 0, then the other answer has to be negative 2. And guess what? These are the x-intercepts. All right, look above to check. Look above in the graph. Let's go ahead and do that. 3 and negative 2, where are they? Well, they happen to be right here. There's positive 3, and there's negative 2, right? So you can see it in the graph, and you can also see it algebraically. So there you go. There's example number 4, full blown. Remember, this is a video, so you can always rewind any portion of it to make sure you understand it, and I suggest that, okay? Look at the solutions, but also use the video well and, you know, do the right thing. Listen to it as many times as you need to. Check your work. If you need to hear me explain it again, hit the rewind button, okay? Come on, this is a video here. All right, number 5. All right, let's do it. We've got expressed in standard form, so that means we got to use FOIL here, as you guys saw me do in the first lesson, because this is in factored form, all right, and I need to express it in standard form. So we got to multiply. So 2x times x is 2x squared. 2x times negative 2 is a negative 4x. 2 times x is plus 2x. And 2 times negative 2 is negative 4. Collect like terms. I'm talking about these right here. I get 2x squared minus 2x minus 4. And now we're going for it. A is 2, B is negative 2, C is negative 4. So A is 2, B is negative 2, and C is negative 4. Take these and substitute them in. So you can see after problem that I'm doing the same thing. All right, and what you need to do is just that. That's how you get really good. All right, let's substitute them in. Negative of a negative 2 divided by 2 times 2 is 2 divided by 4, or x equals 1/2. This is called the axis of symmetry, and it's also a vertical line, and it's also part of the vertex. It's the x coordinate. So we know that the vertex is 1/2 comma something. So the question is, what's the y coordinate? So let's figure it out. Y equals, I got to substitute it right here, x here and x here. I've got 2 times 1/2 plus 2 times 1/2 minus 2. All right. Well, 2 times 1/2 is 1. All right. 1 plus 2 is 2. So this is 2. And this right here is, well, let me see, 1/2 minus 1. I know it's negative. 2 minus 1/2 is 1/2. All right, now negative 1/2 is negative 3/2. So this is the same thing as 2 times negative 3/2. Simplify, and you get negative 3. So y equals negative 3. So I already know my vertex now is 1/2 comma negative 3. Let's plot it and draw your line of symmetry at the same time. So 1/2 comma negative 3 is right here. I'm going to plot the V for vertex at 1/2 comma negative 3. I'm going to draw my line of symmetry. Okay, there's your axis symmetry or line of symmetry at x equals 1/2. It's always a vertical line. And I'm going to pick the points to the right, like 1, 2, and 3. So let's do it. So 1, 2, and 3. And let's plot. Or let's calculate actually. I need to take x and I need to substitute it in here everywhere I see x, which means I have to substitute it in those two locations. So 2 times 1 plus 2 times 1 minus 2. All right, 2 times 1 is 2, plus 2 is 4, times negative 1. All right, and that's negative 4. So that's my first point, 1, negative 4. My second one is 2 times 2 plus 2 times 2 minus 2. Well, that's 0, and 0 times anything is 0. Third one, 2 times 3 plus 2 times 3 minus 2. That's 6 plus 2 times 1. That's 8. All right, so you get 3 comma 8. All right, so let's plot 1 comma negative 4 first. So 1, negative 4. So 1, negative 4 is right here. Well, there's a problem here. What happened? Oh, there is something wrong here. One, two, 2 is 4. Where is my mistake? This is not right. So 1/2. Oh, I put 2 in there, guys. No. 2 is 1. 1 plus 2. Oh, that's 3. 1 plus 2 is usually 3. I found my mistake. It's a good thing I see. Things didn't make sense because I knew this. I knew I made a mistake. So 1 right here. 1 plus 2 is not 2. Okay, it is 3. So I'm going to check. I'm going to correct my errors. This is actually 3, and this is 3. So you know what? Let me get my eraser out and let's fix a few things here. So I made a mistake right here. So let me change my vertex. That's why we use a pencil, right guys? Okay. So this is 1 times 1 is 1 plus 2. Well, that's typically 3. So this is 3 times negative 3 halves, which is negative 9 halves, or y equals negative 4 and 1 half. Why? Because 9 divided by 2 is 4. Remainder 1, or 4 and a half. So I get negative 4 and a half here. So my vertex is 1 half comma negative 4 and a half. Let's plot that. So it's okay, you know it's late, I'm tired, it's 9 o'clock and even doing this for you guys. So 1 half comma negative 4 and a half, there's negative 4 here, negative 4 and a half is right here. So 1 half comma negative 4 and a half. Okay, draw my line of symmetry again, and now I'm in business. Okay, alright, now my first point that I need to plot is 1, negative 4, and this parabola opens up, so I'm expecting that. So 1, negative 4 is right here. Reflect that. Alright, reflect that a half unit across right here, right there. My next point is 2 comma 0, which is right here. It's 1.5 units away, so I go a half plus 1. It should be here. It's reflected across. And 3 comma 8. 3 comma 8. Right 3 up. 1, 2, 3, 4. There's 4, 5, 6, 7, 8. There it is right there. Estimate it. 3 comma 8. Okay, 4, 5, 6, 7, 8. I know it's way up there. Okay, now reflect. That's 1, 2.5. So 1 is right here. So let me see. It's a half. Let me see. We're at 3. So it's 2.5 units away. It should be right about here. Okay, and we reflect it across. Well, I didn't do that right. It should be 2.5, 2.5. There we go, right there. All right. All right, now we draw our parabola. Sometimes you have to, draw it lightly and then, let me see, use your eraser and sketch it. There we go, that's better. All right, top it off. All right, so there we go. There's your parabola. It obviously looks like a valley versus a min. So this is, versus a hill. So this is a minimum value, or what's called a low point. And from there we can determine the range as well. So what we want to do is figure out the y values. So let's just play around a little bit here. This y value is 2. This y value is 1. This y value is 0, and this is negative 1, and this is negative 2. And they're obviously going down because as you cruise down the parabola, the y values are getting smaller and smaller and smaller, but they have a minimum y value of negative 4.5. So this is your min y value. All other y values are above that, okay? And that's why the range is greater than or equal to this negative 4.5, because all the y values are above it. They're greater than it. So let's go down here and let's state the range immediately here. The range is greater than or equal to negative 4.5, and as I said earlier, the parabola has a set of all reals for the domain. So let's state that. Let's go back up to the graph though, and let's find our x-intercepts. I see one right here at 2 comma 0. I see one right here at negative 1 comma 0. All right, and let's state that. So negative 1 comma 0 and 2 comma 0. That's by looking at the graph, okay, but how in the world do you do that algebraically? Well, once again, and hopefully we figured it out by now, that the y is always equal to 0. Look right here, y is always 0. So, okay, so let's write it down. We're going to set y equal to 0, all right, and solve for x. Okay, sorry about all the noise in the background, guys. That's my dog or somebody, I don't know. So let's set y equal to 0. So we get, not y, but we want to do 0 here. 0 equals 2x plus 2 times x minus 2. All right, now this is already factored, so all you do is set each factor equal to 0. Set each factor equal to 0. Man, I don't know if I can concentrate with all this dog stuff in the background. So here we go. 2x plus 2 equals 0. X minus 2 equals 0. Subtract 2. I get 2x equals negative 2. Divide by 2. And it's obvious that it's negative 1. Here, I'm going to add 2. And I get x equals 2. And these are the x-intercepts. All right, you can look above. All right, like I keep saying, look above and check the graph and verify. Okay, and that's your 5th problem. Okay, last and final one. Let's go ahead and take a look at this one here. Okay, guys, sorry about all the interruptions there. So let's get right into the last example here. All right, we have to get in standard form, and again, standard form, if you recall, is ax squared plus bx plus c. And guess what? There's no middle term in here. So what does b have to be in order for there to be no bx term? Say it out loud, man. Bring it on, guys. What does it have to be? That's right. It's got to be 0. There's no middle term. We know that 0 times x is 0, and that's why it's not there. All right, so we know that this function is negative x squared plus 0x plus 9. There's no middle term, and that's why b is 0. All right, we know that a is negative 1, b is 0, and c is 9. So let's write them down. All right, a is negative 1, b is 0, and c is negative 9. Excuse me, positive 9. All right, there's a plus sign there. All right, and let's take these. Let's substitute them in. And let's find our axis of symmetry. So we got x equals negative 0 divided by 2 times negative 1. That's 0 divided by negative 2, or simply x equals 0. And this is our vertical axis of symmetry. All right, axis of symmetry. We're going to take this coordinate here, substitute it in, and we're going to find the y value. And we've done this before. I just changed the little numbers here. If you look back on your previous examples, like number 2, I think it was. All right, this right here was, instead of 9, it was 4, I think. But, you just go with the flow. We know that it's 0 comma something. So what is negative 0 squared plus 9? Well, that's not too hard to figure out. Negative 0 squared plus 9 is 0 plus 9, or 9. So the y is equal to 9. And now I know my vertex. Well, I know my vertex is 0 comma 9. So we're going to plot it. Okay, so here's 9, 0 comma 9. There's my vertex. I know my axis of symmetry here is runs right through the vertex. So I plot that here, and now I'm going to pick the numbers to the right of 0. Right? Well, how about 1, 2, and 3? All right, let's pick these in our table. That's how you determine that. So 1, 2, and 3. 1, 2, and 3. Take all these values, substitute it in, and go for it. So what is negative 1 squared plus 9? Well, you square the 1 and not the negative because it's not parentheses. Okay, so this is negative 1 plus 9, or 8. Next one, what is negative of 2 squared plus 9? Well, that's negative 4 plus 9, or 5. And last one, negative 3 squared plus 9. That's negative 9 plus 9, or 0. All right, now let's plot these and reflect them, and then we'll be almost done. Can't even spell right at the moment. It's too late. Okay, plot and reflect. Okay, 1 comma 8. All right, we got 1 comma 8. Right 1, up 8. Reflect it. Next point, 2 comma 5. Right 2, up 5. Reflect it. Next point, last point, is 3 comma 0, which is right here. Reflect it at negative 3. Okay, reflect each point. As I've said continuously, that helps you graph your function. All right, and this parabola opens down, obviously. So this is going to represent more like a hill or a mountain versus a valley. All right, and mountains, and they have peaks, right? And peaks are high points, and high points are maximums. All right, max for short, they're maximums. And so the question is, what's the max y value? Well, here the y value is 0. Here the y value is 1, and here it's 2, and here it's 3, and here it's 4. All right, what's the max y value? Well, hopefully you figured this out. The max y value has to be 9. So max y value equals 9, which means all these other points like 8, 7, 6, 5, 4, 3, 2, 1 are less than or equal to it. And that helps me figure out the range. So I know my range is y less than or equal to 1. You have to look at the vertex each time in order to figure out the range. Okay? The domain, that's easy. It's all reals. Okay? All reals. There's your symbol for it. Now, what is everything else? Well, let's finish up here. Well, I see some intercepts here, right? I see an x-intercept here at 3, 0. I see it right here at negative 3, 0. These are x-intercepts. So let's write them down. Negative 3, 0, 3, 0. Now, how do you get that graphically? Or excuse me, we just did that graphically. How do you do it algebraically? Well, you set y equal to 0 again. All right, and solve for x. Okay, I've only said it for the 8th time in a row. 2 times in my prior lesson and 6 more times in this lesson here. You set y equal to 0. So right there you let y equal 0. So 0 equals negative x squared plus 9. Well, let's add the opposite. So I've got x squared equals 9. Take the square root. All right, and you get x is equal to plus or minus 3. All right, so that tells me since y is 0 here, I've got 3, 0, and that tells me we got negative 3, 0 for my x-intercepts. And obviously, look above to check. All right, and that's all there is to it. So what you need to do now is that now that you've experienced all of this, is you need to ask yourself the question: do you understand it? Can you do it by yourself? And if you can't, go run through this whole process again, because it's the same thing for every quadratic. You just got to get used to it. And the way you do that is through pure practice. So that's what we're going to be doing today and tomorrow and the next few days with you guys to get you guys the experience that you need. All right, and remember, this is a video, so you can rewind and listen to any other example that you like to, again and again and again, as long as it takes to fully understand the function and the problem. All right, this is Mr. Ainsworth. I'll see you in my next lesson. I'm signing off. I'm tired. I'll see you then. Bye-bye.